the 21st century, throughout the world development continues to progress rapidly. Industry is growing by leaps and bounds, and cities are overflowing with people. At the same time, mass production and mass consumption are generating volumes of waste so huge that sometimes authorities are unable to cope, giving rise to mountains of waste. In many cases, the inappropriate management of waste results in water contamination and other forms of pollution. In the 1950s and 60s, when Japan went through a period of high economic growth, it faced similar waste-related problems arising from rapid urbanization, including increases in waste volume and worsening of the sanitation environment through ineffective waste management. In response, the government revised and enacted various laws relating to management and disposal of waste, and undertook measures such as the construction of disposal facilities and the development of technology. While progress was made in the sanitary disposal of waste, the amount of waste generated continued to grow, making it difficult to secure adequate disposal facilities and to handle disposal volumes. In an effort to improve this situation, since the 1990s, recycling laws have been employed. In 2000, the Basic Act for establishing a sound material cycle society was enacted, establishing the foundations for a policy that prioritizes the 3 R's: reduce, reuse, recycle. There is a word in Japanese, mottainai. It means it's a pity to waste things and encompasses the practice of treasuring things as long as possible. The spirit of mottainai applies to the policy that prioritizes the 3 R's. Today, as a part of the effort to prioritize the 3 R's in Japan, waste from households is sorted prior to collection, in line with the slogan, "If it's mixed, it's waste. If it's sorted, it's a resource." As for difficult to recycle combustible waste, volumes have been reduced by about 90% through incineration, while the thermal energy generated as a result of this process is utilized effectively in things like power generation and water heating. Ash and other materials left at the end of the incineration process are disposed of as landfill. Today, Japan's waste management and recycling technologies and systems are among the most advanced in the world. Let's take a closer look at some of these technologies and systems. This is a waste incineration facility built and operated in one of Tokyo's busiest shopping and entertainment areas, Ikebukuro. Each day, an average of 320 tons of waste is delivered to this waste incineration facility for burning. The reason that a waste incineration facility such as this exists in such a densely populated area is due to the application of advanced incineration technologies and systems that meet Japan's strict anti-pollution regulations, which have been approved by local residents. As of 2009, there were 1,243 municipal waste incineration facilities throughout Japan. A variety of incineration methods are used, but stoker furnaces account for 70% of all furnaces. In a stoker furnace, waste is agitated and dried as it is carried along, ensuring it is burned completely. Other types of furnaces include fluidized bed furnaces, and gasification fusion resource furnaces, which enable ash recycling. In addition to using advanced environmental preservation technologies, all of these furnace types employ technologies for stable operation, such as automatic incineration devices and automatic cranes. The number of high-efficiency power generation facilities is increasing in Japan. Waste incineration generates harmful substances such as hydrogen chloride, sulfur oxide, nitrogen oxide, and dioxin. In Japan, solving dioxin pollution became an urgent issue with respect to waste incineration, and an enormous amount of research was conducted by both private and public sectors. This research led to the development of countermeasure technologies, resulting in improvements in control methods and operation methods to ensure stable combustion. One example of this is the introduction of complete combustion technology, which reduces dioxin emissions to virtually zero. Another example is the introduction of exhaust gas cooling technology, which prevents the resynthesis of dioxin. Yet another is the introduction of dust collection technology, which prevents dioxin from escaping. In this way, dioxin emissions from waste incineration facilities in Japan were reduced to below the strict government-regulated values. By 2003, total dioxin emissions in incineration facilities throughout Japan decreased as much as 98% compared to 1997. Today, waste incinerator facilities in Japan are gradually being upgraded to state-of-the-art facilities that ensure low pollution, stable operation, and high-efficiency power generation in an effort to counteract global warming and meet the country's commitment to the 3 Rs. Improvements in electricity generation efficiency not only enable such facilities to meet their own electricity supply needs, they also provide a source of income by enabling them to sell surplus electricity to power companies. As for the ash left over from the incineration process, as well as disposing of it at landfill sites, efforts are being made to use it as road subbase material. One example is by melting ash at high temperatures and turning it into non-toxic artificial aggregate. Today, Japan's incinerator facilities are undergoing a transition to facilities that are reducing the total amount of waste disposal. These facilities are also safe and secure and able to recycle ashes and generate electricity, adding to the many merits of Japan's waste incineration technology. With the capacity to handle diverse types of garbage, ranging from low-calorie garbage to high-calorie garbage, Japan's world top-class garbage incineration technology is destined to make an increasingly valuable contribution in a rapidly urbanizing Asia, not only by improving public health, but also by protecting the environment. Another problem related to waste management is disposing of home appliances. Home appliances contain lead, copper, flame retardants, and other harmful substances that can pollute the environment. And if disposed of without treatment at landfill sites, they can cause water or soil pollution. At the same time, electrical products such as personal computers and cell phones are so full of recyclable materials, they are sometimes referred to as urban mines. For these reasons, it is vital that there be a transition from disposal of them at landfill sites to more suitable management such as recycling, in which valuable resources are recovered. In 2001, Japan enacted the compulsory law for recycling of specified kinds of home appliances, which applies to 4 kinds of home appliances: air conditioners, TVs, refrigerators, and washing machines. A vital component in the disposal of used home appliances is the recovery of highly pure recyclable resources and the development of technology enabling this recovery. Emphasis used to be on breaking down appliances and sorting recyclable parts using magnets. Today, a more sophisticated approach has been adopted in sorting and recovering resources. In order to increase the purity of recovered resources from TVs, for example, appliances are first taken apart and sorted manually. They are then crushed and sorted by machine, enabling not only metallic material but also plastic parts to be recovered for recycling. Refrigerators and air conditioners contain chlorofluorocarbons that damage the Earth's ozone layer, so the utmost care is taken to protect the environment through effective waste management such as recovering liquid chlorofluorocarbon and chlorofluorocarbon in insulating materials. These and other advances in home appliance recycling technologies have made the efficient recovery of valuable resources possible. Among those Japanese companies that possess advanced recycling technologies, there are some that have already expanded overseas. In Japan, considerable attention is currently being focused on the active utilization of biomass. There are difficult problems associated with the management of waste with high moisture content and biomass, such as food production waste, as well as household kitchen waste, barn animal manure, and sludge. Such waste generates methane gas and hydrogen sulfide when buried without treatment, causing environmental pollution. Incineration of such waste requires submaterials to assist with incineration. More and more companies and municipalities are seeking to actively utilize biomass by turning it into feed or fertilizer, or are using it for methane fermentation. In Hita City, Oita Prefecture, an operator commissioned by pig farms collects hog manure, kitchen waste from homes and businesses, and sludge from an effluent treatment facility and transports it to a fermentation facility. This kitchen waste, hog manure, and sludge is used to generate electricity and to manufacture fertilizer, including liquid fertilizer and compost. In Japan, where tempura and other deep-fried foods are an important part of the food culture, there are cities that have developed edible oil waste recovery systems for the conversion of waste oil into fuel for city-operated buses and garbage trucks. Among Japanese municipalities, there are those that use biogas derived from sewage sludge, collected at sewage treatment plants, not only to generate electricity at treatment facilities, but also as fuel for city-operated buses. In Asia, where biomass makes up a large portion of the total waste volume, Japanese technology is used in generating power from bark and wood debris to meet local electricity demands. Technologies and systems for the efficient collection and transportation of waste developed in Japan to date. Urban waste incineration technology, which enables safe and sound high-efficiency power generation. Recycling technologies tailored to suit the characteristics of individual commodities. And landfill disposal technology that enables stabilization of waste in a short time. All of these technologies make a major contribution to achieving environmental conservation and in solving waste management and recycling problems in countries around the world. We recommend the use of these world-renowned Japanese technologies in your country.